Cornwall. This event is organised by the Institute of Physics, the national body for physics, which is really keen on helping not just academia, but industry and education in promoting physics and science across the UK. Really pleased with today's lineup of special guests. We have Goonhilly, we have Spaceport Cornwall, we have the Aerospace Centre of Excellence, and I'm really looking forward to hearing about the plans for Cornwall, the space sector, and also the related space applications industry. So I hope you all enjoyed today's session. We have got a great lineup today. Save your questions. There will be a chance for you to ask and enjoy. Thank you very much.
Hello and welcome to this Institute of Physics presentation. My name is Dave Pollard and I'm the Education and Outreach Manager at Spaceport Cornwall. Today you're going to get to hear from myself, Virgin Orbit, Goonhilly Earth Station and the Satellite Applications Catapult, and learn all about the developments in the space sector in Cornwall. So first of all, about me, I'm the Education and Outreach Manager at Spaceport Cornwall. So I work with students from primary school level right up to sort of post university, so masters and doctorate level, to engage them in space and the opportunities that it gives, but also to work with the institutions to make sure there are courses there being put on to help with our sort of talent pipeline into the sector in the future. So I work for Spaceport Cornwall. We're a fairly small team, and Spaceport Cornwall is going to be the first launch site, and we're going to have the first launch in 2022, which will be the first ever launch in the UK. So we're super excited about that. We have partnered with Virgin Orbit, who you're going to get to hear from later, who will be using us as a launch site. And we're also able to work with other launch partners in the same way that the airport has many different flight providers. We're able to work with different space organisations who may want to use the spaceport as a takeoff area or possibly as a landing zone. So you may have heard recently that we've signed a memorandum of understanding recently with Sierra Nevada Corporation, who will be hopefully using us in the future. I'm now going to show you a quick video about Spaceport Cornwall, who we are and what we do. So hopefully that gives you an indication of who we are and what we do. And I think it's a really exciting time for Cornwall. The space sector is developing at a pace. We've already got Goonhilly Earth Station, which is a world-class Earth station. We've got the satellite applications catapult, we've got Spaceport, and we're already in discussions with other organisations who want to be down here and close to launch. And if we can develop that cluster well, then there's going to be high-skilled, high-paid jobs for a future workforce. And students are going to be able to see what they want to be in the future. But also people like you who maybe work in a specific physics profession may think about opportunities of developing into the space sector, or your business using space to help what you're currently doing. And I think all of those opportunities will be here. There's good pots of funding available for research and development through Aerospace Cornwall and the Satellite Applications Catapult. And hopefully that's something that you guys will consider and be interested in. So my role at the Spaceport is all about inspiring the next generation. And in one way, it's a very easy sell. You know, I think space is a fantastic hook into STEM or STEAM. I always like to say, but it's about ensuring that there are courses and provision there in the future. So we've had some great news recently about Truro and Penwith College developing an Institute of Technology, and they're going to have some space-related courses that they're going to be offering. And also the universities in the local area are really starting to get on board with wanting to offer courses relevant to the space sector, whether that's the upstream, so actually putting things into space, the engineering side of it, or the downstream. So once those satellites are in space and the data is being transferred back down to Earth, how can we use that data to create new products, to create new apps to sort of benefit us commercially, but also environmentally or through health? And those areas are where I see a lot of opportunity in the future, because there's so much data already coming back from space. But it's how do we use that data to really make positive change here on the ground, or support our health or our environment through apps and sort of data analysis. When I talk about courses, there's another one that I haven't mentioned yet, which is Launchpad, based at Falmouth University. This is actually a funded business entrepreneurship masters. So people will get paid £16,000 to study on that. But whilst they're on that course, they've got to create a business with other students that are on the course. And a lot of the businesses that have come out of that have used space data or space technology to create their products. So it'd be impossible to be here without talking about the elephant in the room. So behind us, we have the Launcher 1 rocket, which is Virgin Orbit's launcher, and that will sit on the wing of a Boeing 747 called Cosmic Girl. So Virgin Orbit sent the Launcher 1 rocket over to us for G7, so that we could show the world leaders the developments in Cornwall. And they're also leaving it with us for the next 3 months, so that we're going to be able to put on an exhibition to engage students, young people and the public in Cornwall about space and the developments locally, which we're super excited about. I won't talk to you too much about the rocket, because Virgin Orbit will be coming on to speak to you in a more technical way about their launch capability later on in this presentation. But I'll move on now to talk to you about some of the future developments at the Spaceport. So we're at a process of just putting up our first few buildings. So we are developing a Centre for Space Technologies, and within that we will have a satellite integration facility. So that will be the area where the fairing will have the satellites put in ready for launch. And it's great to have that here close to the launch site, because the satellites are such fragile payloads sometimes that the least distance that they can travel to launch is really important. We're also going to be developing workspace for SMEs and research space for universities or researchers who may want to use the facilities in the future. And I am also going to have a very small educational space where I'm going to be able to host sort of 30 students at a time, or small groups of people at a time, to enthuse them about space and inform them about what's happening locally. So I mentioned the fairing, and this is actually a real half fairing that will sit in the nose cone of the Launcher 1 rocket. Once that rocket gets up into the appropriate orbit, then the half fairing will start to release the satellites. And the satellites sit where you can see the three TV screens here, and then they'll be spring loaded and release out into the appropriate orbits that they need to be in once they get there. I'm going to draw to a close now because I've only got a limited amount of time, but you're going to get the opportunity to ask questions at the end of these presentations. So please do think about these questions and I'd be happy to answer them. But thanks very much for listening. So hopefully that gave you a bit of an insight into Spaceport Cornwall, who we are and what we do. Your next presentation is going to be from Virgin Orbit. Virgin Orbit were hoping to be on the call today, but if any of you saw, they actually had a launch today, which happened just a few hours ago. So they're not actually able to make it on for the Q&A, but they pre-recorded this for you. And the launch went really well today, absolute success. So if you haven't seen it, I would highly suggest watching that back because they did a full live stream of it on YouTube. So I'll now pass over to Michael Lynn from Virgin Orbit.
Well, hello, everyone. I am so happy to be here to share a little bit about Virgin Orbit and what we do here. My name is Dr. Lynn Thomas, and I'm the head of affordability, and I'm also the project manager for Spaceport Cornwall here at Virgin Orbit. Today, I have the great opportunity to share just a little bit about what we do here at Virgin Orbit. So without further ado, let's dive on in. Okay, so here on the left is Virgin Orbit, and we are focused on launching small satellites into space. Now, Sir Richard Branson here, he also has Virgin Galactic, and they are focused on space tourism. But today, our talk is going to be on Virgin Orbit. Here's our cool team. We have such a unique team made up of brilliant rocket scientists, engineers, business folks, brand and communications people, attorneys, and so much more. And it really takes our diverse talents to come together to build our amazing rocket. Now, here's just a picture or a snapshot of our system. So on top here is Cosmic Girl, and she's a modified Boeing 747, also known as our flying launch pad. On the bottom here is our Launcher One rocket, and we build and manufacture everything right here in Long Beach, California. And I wanted to share just a picture with you all of Cosmic Girl and Launcher One in action. Earlier this year, back in January of 2021, we had our first orbital mission, and we launched many student university payloads into orbit. It was such an exciting day, and you can see Cosmic Girl on top, and you can see Launcher One here with its engines ignited. How exciting. And I wanted to share a glimpse of some of the cameras that we had on Launcher One. So on the top here, you can see Launcher One's main stage falling back to Earth shortly after separating from the rocket's upper stage during our Launch Demo 2, as I mentioned, was earlier this year. And on the bottom, we also had a camera nestled in our Launcher One's fairing, which captures a glimpse of our first customer payloads shortly before its deployment. So really, really exciting and cool shots that we were able to take. And here's a glimpse of our factory here in Long Beach, California. So this is my cool office. You know, there's nothing more exciting than walking around and seeing awesome rocket hardware in production. And now diving just a little bit deeper into our Launcher One system. It's a two-stage rocket. And starting on the left over here, we have our Newton 3 engine, which gets about 75,000 pounds of thrust. And also our first stage here, you can see, is primarily made up of carbon composites, if you will, so a carbon structure. And we also have our second stage, also made up of carbon structures or composite structures. And we have our Newton 4 engine, which gets about 5,000 pounds of thrust. And at the top here, in our vehicle fairing, the customer payloads go inside there. And on the bottom, we have our Cosmic Girl system, as I mentioned, our modified Boeing 747, which is our flying launch pad. All right, and here's just a deeper picture of our Newton 3 engine. So you can see here that our rocket technicians, they're getting this Newton 3 engine prepared for vehicle integration. And so looking at our structures, Launcher 1 is largely a composite vehicle, as I mentioned earlier, made up of mostly carbon fiber. And our engineers here at Virgin Orbit address the complexities associated with manufacturing a robust, lightweight vehicle that must be able to withstand both horizontal and vertical loads. Now, diving just a little bit into our material science and manufacturing, here at Virgin Orbit, we are always pushing the envelope on how orbital class rockets are flown and built. We use additive manufacturing, which allows us to increase performance of components while decreasing cost, lead time, complexity, and part count. We also use powder bed fusion, which uses a layer by layer powder bed approach in which the desired component features are centered using a laser, which are subsequently solidified. And we also use directed energy deposition, which is a free-form fabrication process using a coaxial laser and powder blown into the melt pool to create these unique features. And so avionics and software. So avionics is really like the brains of the system. And we have engineers, technicians, and our test team who design, build, and verify this great system. So here's a little flyer. So exciting. So we test all of our parts, our rocket parts out in Mojave Desert. And here you can see our Newton 3 engine going through a hot fire test. And so a little bit on vehicle integration. On the left here, Launcher 1 is being prepped to be shipped to the launch site to mate to our carrier aircraft Cosmic Girl. And so you can also see here that, for our most recent mission, which was earlier this year, how Launcher 1 and Cosmic Girl are mated at the Mojave Air and Spaceport. And so our launch and ground operations team fuels Launcher 1 from the Mission Control Center. And our flight crew departs for launch to deliver the rocket to the drop zone. Now, as I mentioned earlier, I'm one of the project managers for spaceport development. And so Virgin Orbit has announced that we will be launching from Mojave, California, Cornwall, United Kingdom, Guam, as well as Oita, Japan, and most recently, Alcantara, Brazil. So we are bringing horizontal launch capabilities to wonderful places all around the globe. And Spaceport Cornwall, how exciting. So we have plans to fly from Spaceport Cornwall as early as next year. And most recently, we have partnered with ABS, which is a United Kingdom-based manufacturer. And they are going to help support us with a transportable ground operating system, also known as TGOS. And that will support launches from Spaceport Cornwall. So here at Virgin Orbit, we are creating the new normal for launch, and we are so excited to have our horizontal launch capabilities around the globe. So thanks everyone today for tuning in. It's been an absolute pleasure. I'm so happy to be here. And I hope you learned just a little bit more about the cool things that we're doing at Virgin Orbit. Have a wonderful day.
Great. That was great to hear from Michael Lynn. I hope you found that interesting. I actually, when I gave her a bit of a brief, I asked her to focus on sort of more of the sort of engineering specifics. Some of that, I'll admit, I didn't quite understand, but I've been on lots of presentations with her in the past, and they have mentioned that they use sort of 3D printing quite often, and that's bringing down their lead times to create parts from months to a matter of days. Which I just thought is incredible to hear. So we've heard about sort of the takeoff and actually getting satellites up into space. Next, you're going to get to hear from Olivia Smedley from Goonhilly Earth Station to learn about how we're able to get some of that data down from the satellites to sort of mission control facilities and satellite receiver dishes like Goonhilly.
Okay, so welcome to Goonhilly Earth Station. I'm Olivia Smedley and I'm a space scientist working here at Goonhilly. So right now we are by the antenna farm where we have lots of our antennas communicating with different spacecraft that are in orbit around the Earth. So we are supporting all different types of missions here, from geostationary satellites to low Earth orbiting satellites. So you can see some of the antenna in the background here are stationary, and they are actually looking at some geostationary satellites and communicating with those. Now, geostationary satellites orbit around 36,000 kilometres above the surface of the Earth, above the equator, and due to this orbit, they actually have the same orbital rotation period as the Earth's rotation period. So they stay in one spot over the Earth as they orbit around. On the other hand, we also support low Earth orbiting satellites, which move a lot quicker across the sky. They're much closer to the Earth and can orbit the Earth in around 90 minutes. So we need antenna that can actually track these fast moving satellites. And you may actually see the front dish here moving quickly to track some of those satellites. So we support a whole host of different types of missions here, from near space to deep space. Here we are at Goonhilly 6. Goonhilly 6 is the largest antenna that we have here on site, and it's 32 metres in diameter. It was originally built in 1984 and used to communicate with geostationary satellites. However, as technology has improved, we no longer need these large dishes for communicating with satellites that are in geostationary orbit. So after months and months of upgrading, this antenna is now capable of deep space communications, so communicating with spacecraft that are as far away as the Moon and even Mars. Here we are in the main equipment room of Goonhilly 6, and here we house all the equipment that enables us to communicate with these spacecraft that are in deep space. So my role is part of the operations team, and over the last couple of months we have been undergoing mission readiness testing with the European Space Agency to enable us to support their Mars Express mission. Mars Express is a Mars orbiter, and Mars is actually over 1/3 of a billion kilometres away at the moment, which means that when we send a signal to the spacecraft, it actually takes 40 minutes for the light to travel there and back to Earth. We actually sent our first operational command to Mars Express a couple of weeks ago, which was to fix an issue on board the spacecraft. So that was extremely exciting. And we have lots more exciting missions that we're going to be supporting with Goonhilly 6, other European Space Agency missions such as Integral and Gaia. And we have also recently announced that we'll be supporting Intuitive Machines mission to land on the Moon, and that launches in early 2022. Goonhilly 6 is just one of the antenna we have here on site at Goonhilly Earth Station, and we have lots more exciting projects going on here as well. So thanks very much for watching, and I hope you've enjoyed learning a little about what we do here.
That's brilliant from Olivia. I hope you found that as fascinating as I did. I got to watch that video last week and I learned a lot about Goonhilly. And you're going to get to ask Olivia and the CEO of Goonhilly, Ian, questions at the end of this. So if you have any, please start thinking about them now. So we've learned about getting satellites up into space, how we bring that data back down to Earth. Now we're going to hear from Conrad Gillespie from the Satellite Applications Catapult, who's going to talk to you more about what can be done with that data and what opportunities there are.
presentation, please. Okay, so the UK government has high aspirations for the space sector, having committed significant investment to build national capabilities, support STEM initiatives, and grow international collaborations. Space is also becoming more commercial, and innovations are being accelerated with a wealth of ongoing funding opportunities. And here is the current UK space ecosystem, led by the Satellite Applications Catapult, UK Space Agency, and the European Space Agency, ESA. The network connects regional centres, including the Southwest Centre, and new space clusters are currently being developed throughout the UK. We can provide wide-ranging facilities, technologies, and equipment to support innovators with space-related concept ideas and the research and development of new innovative products and services. Most of these facilities are within the Harwell Space Cluster. However, Goonhilly Earth Station is a key partner. The Southwest plays an important role in the thriving UK space economy. The aim is to help to grow the Southwest Space Cluster by supporting innovators and researchers to develop and commercialise space technologies and satellite applications. Centre partnership includes the Universities of Exeter, Falmouth and Plymouth, and our coverage includes Cornwall, Devon and Somerset. We have a number of critical friends, including the UK Space Agency, ESA Space Solutions, Spaceport Cornwall, Virgin Orbit, Goonhilly Earth Station, and Aerospace Cornwall. And we also collaborate with other regional business support initiatives, and some are listed here. So we engage with the whole of the space ecosystem to help businesses to commercialise upstream space technologies, including advanced materials, emerging technologies, clean energy, and space law, for example. We also help with wide-ranging downstream satellite applications for non-space sectors by empowering products and services with Earth observation, satellite communication, and navigation services. From a technical point of view, we can help innovators with universal connectivity, which is vital for autonomous vehicles and their development, for example, geospatial intelligence, including Earth observation imagery for environmental intelligence, access to space, which includes launch and microgravity services, and emerging technologies, including OneWeb, 6G communication services, and manufacturing in space. Here are just some of the key markets that the Satellite Applications Catapult are getting involved in. So if you're interested in developing your career or work in these particular areas, then satellite applications can definitely help you. And within the Southwest, our key downstream focus areas are e-health and e-wellbeing, marine and maritime, mining, and natural capital. So within e-health and e-wellbeing, satellite applications can have a crucial role to play in improving how healthcare and wellbeing services are delivered by providing remote monitoring and early diagnostics for people living in remote and rural locations, for example, and facilitating advanced medical decision-making services. Within marine and maritime, data from space is vital to the maritime industry, including the tracking the location of vessels and seagoing traffic for the sake of safety and economic efficiency. It also plays an important role in monitoring the marine environment and its sustainability. Within mining, satellite technologies can create operational efficiencies within the mining sector, whilst empowering local communities and improving environmental sustainability. And for natural capital, Remote sensing data can unlock the value of our natural capital, including agri-tech, environmental intelligence, and sustainable productivity, which can lead to wide-ranging social, economic, and environmental benefits. So, here are some of our key offerings, and they include horizon scanning and insights around key market challenges and funding opportunities. We connect people and can coordinate and support collaboration from key stakeholders. We have open space hubs, which is a network of collaborative offices and hot desking facilities that we can provide to startups, innovators, people with bright ideas throughout the region when it is safe to do so and the time is right to open back up. We have thematic specialists in the focus areas mentioned earlier. Also, we offer a range of business support initiatives like the Space Tech Business Incubation Programme for startups, challenge workshops, technical experts to help innovators accelerate their innovations. And we foster project consortia for collaborative funding proposals, including international collaborations. So in terms of current funding opportunities, here's just a selection. So DASA and DSTL are seeking innovative ideas to promote space resilience and develop future space technologies to enhance and protect space military, but also civil protection. In terms of ESA Space Solutions, these are some of the funding opportunities available at the moment, and they're very diverse. So there's one around smart and uncrewed shipping, all around marine innovation. We have one on space for hydro energy sector, and there's lots of different funding calls coming out around clean energy. We have one on future hospitals and health innovation and meditech. But also, we also have a call to help with the rail industry and also safety and security. And there's lots more, there's more coming out, and we can get people together, and it really doesn't matter who the funding or funder is. It could be Innovate UK, UK Space Agency, or a whole wealth of other funders out there. So please contact me to explore further, and we can collaborate, make things happen. And just a bit of a flavour of some of the collaborative projects that we're involved in at the moment. So again, they're very diverse. This one is called Connected Healthcare, and it's led by Goonhilly Earth Station, and it's all around people living in rural and remote areas in Cornwall and Scotland to have satellite-enabled services, including live video feeds, their doctors, and elsewhere. And the future is all about remote sensors, also AI, and then humans adding value when needed. Another one is called Cybership, and so it's a maritime cybersecurity project, and it's an important growth area. So our Marine and Maritime lead from the University of Plymouth heads up the Cybership Lab to improve maritime safety and security. And we're also involved in the development of autonomous vehicles in the Plymouth area, including autonomous scientific boats, submarines, and floating offshore wind farms. And then within mining and extractive industries, we collaborate in mining and extreme environment projects. Some are outlined here, and we're also helping to build an autonomous mining robot. So again, we can get involved with engineering and upstream services, but also exploiting space data for really good applications, including environmental intelligence. So there's lots of other examples for beneficial space-enabled applications, including climate resilience, tackling deforestation and sustainable food production. So if you'd like to get involved with the Southwest Space Cluster, we're happy to explore ideas and opportunities with you. But let's connect. We're here to help. and happy to answer any questions a bit later on. So thanks a lot.
That's brilliant. Thanks, Conrad. Hopefully you all found that really interesting. I thought it was really important to include in case you're thinking about diversifying your business or starting up in a new area, and Conrad and the Centres of Excellence can really support that. So that's the end of the actual presentations that we're going to give you. We're going to give you a 10-minute break now, and I'd like to say a huge thank you to Stephen for being our BSL interpreter today. We've never done a presentation with a BSL interpreter, and it's just been great to have you. So we're going to have a 10-minute break, and we'd like you to submit your questions into the question panel. And then when we come back, you're going to have Conrad, myself, and then Olivia and Ian from Goonhilly Earth Station, who will answer the questions that you have. wanted to show you a quick video prior to doing the Q&A. So this is a video from Virgin Orbit's first launch, which was in January. And I thought it was just quite important to see this video on this broadcast, and then we'll go straight into the questions afterwards. Thanks for all the questions that are coming in. Feel free to sort of submit any more throughout the next sort of half hour, 40 minutes.
Elsie, this is Albion Control Room. We are currently on track for our nominal timeline, and our current drop time as listed in Trillion is 19:25 UTC.
Planet controller and flight crew has been boarded the aircraft.
Cosmic Girl, this is Orbit Base. You are go for takeoff.
Copy, go for takeoff.
Altitude 3000.
And Orbit Base, Cosmic Girl is starting the turn to the inbound. Pulling now. Pull.
Pulling.
Release.
Release, release, release.
Release.
EST's ignited.
Confirm Newton 3 engine startup.
Max Alpha achieved.
TBCs in first stage looking good.
We had a pretty awesome view up here.
Max Q Alpha achieved.
Stage 1 burn nominal.
Stage set, brake wires broken.
Newton 4 startup complete.
Recovered, and we are now returning to base.
Bearing, brake wires broken.
Launcher 1's in space. Sounds like the blue skies went to black.
This is Radiohead on control. Mauritius has confirmed acquisition. Payload separation confirmed.
So I thought it was just quite important to include that today, because that took place in January, but it's actually also taking place today, and that's the exact same technology that will be coming across to Cornwall next year. So going to get on to the questions now. We've had some great questions come in already. So I will start with the first question we had in, and I'm going to pass over to Olivia for this one, I think, and that is, what STEM careers can young people in Cornwall look forward to?
Yes, I think it's a really exciting time for space in Cornwall at the moment, and there will be so many opportunities in STEM careers. So here at Goonhilly, for example, we have a real range of roles on site, and we have people from lots of different backgrounds with lots of different skills, from mechanical engineering backgrounds to astrophysics backgrounds like myself. So on site at the moment, we've got a real growth in the deep space operations side of things, and there will be lots of opportunities in operating our deep space antenna here on site. And I've actually been part of that team and learning and building up my skills with how to do that. So it's a really exciting time, and not just at Goonhilly, you know, with Spaceport Cornwall and all the other companies in space in Cornwall. There's going to be a growth and real opportunities in different STEM careers.
Great, thanks, Olivia. Just putting you on the spot, but what was your route into the sector and into the job that you're in now?
Yeah, so, well, I've always had a passion for space ever since being young, and kind of dragging my telescope out across the garden to look at the stars. So I kind of followed that passion through and studied astrophysics at Bristol University for my undergraduate. After that, I actually decided to go into teaching, and I taught secondary school physics for a number of years before deciding I wanted to get into the space industry myself. So I started studying for a master's in space science and technology with the Open University, which I'm still actually studying towards now part-time. So yeah, that, and then I got a role at Goonhilly a couple of years ago. So it's an amazing place to work and so many exciting things happening. So yeah.
Amazing. That's great. Thanks for that. I'm glad I asked that question actually, because that's a fascinating route into the sector. Okay, I've got a question next for Conrad. I'm going to combine two questions. So one was, what are some examples of space applications using data from space? And then someone else has asked, who works in the NHS, has asked about how satellite applications can help their patients. So if you've got a few examples of sort of general uses and then some around health, that would be brilliant.
Yeah, certainly. Yeah, so when it comes to space-related applications, so from the Earth looking outwards, satellite data can really help. So we're working with researchers to explore and search for exoplanets, for example, and also space weather and microgravity services. And we're also talking to small SMEs that have got some amazing ideas about developing and designing a rover for the moon or Mars to be able to collect water samples or minerals, for example. So satellites are needed to be able to communicate with these rovers and autonomous systems effectively. So that's looking out. But then basically exploiting space data, looking down to Earth, is massive when it comes to environmental intelligence. So recently we've done a project with Cornish Lithium using satellite data or Earth observation imagery, and also other things like radar, multispectral, hyperspectral, to look down at Cornwall and try and discover where in Cornwall could be good potential places to mine for lithium. So it's very cost effective and also very sustainable. And so countries like Australia would be really interested in that type of technology, huge landmass, massive mining sector. So that's just one example. But also we're working with researchers and companies around ocean health. So you can use satellite data to monitor the carbon levels in oceans, also track plastic waste in the seas, also crop health. So there's lots of green futures initiative going on, and air quality, for example. And then also working with companies in South America, looking at tailing dams in the mining industry and other sectors as well. So the bottom line is satellite data can help in lots of different industries and sectors, including finance, construction. And so if you want to find out more, please contact me and I can provide more information about particular examples. And then the second question around health and well-being, I mentioned the Connecting Healthcare project. I can send more information. There's a link out there, but also some of the other applications are a project that we call Connected Ambulances. So this is all about if someone's in an accident, by the time the ambulance arrives, it's got some really good data and information about that particular individual. And so by the time that individual gets picked up and taken to hospital, it's all about information to make quicker, better decisions. And again, yeah, I could provide more information on that. Another health and well-being one is called PillCam. So actually using satellite data, believe it or not, for a pill with a camera that you swallow, and it basically goes through your system and detects using machine learning, AI, and computer vision problems that could be developed. And now that going forward with medical robots floating around your body and detecting issues, you know, that's a big growth area in itself.
Every time I hear about different apps and different ways that satellites and space data are being used, is just absolutely fascinating. And I think especially in health, So yeah, thanks for that, and thanks for the questions. I've got a few questions coming in for me around sort of the launch of one rocket and what fuel that runs on, and also when that rocket is on the wing of the plane, does it affect how the plane flies? So the launch of one rocket has a mixture of rocket propellant one, which is a highly refined kerosene and liquid oxygen, and it's when those two combine that they're able to get the propulsion that they need. And then in regards to the launch of one rocket being on the wing of the plane, it doesn't really affect the plane a particularly large amount. So where that rocket is docked, that was actually when it was a Virgin Atlantic plane, that was where a spare engine could be transported across the world. So I don't know what the weight difference is in that, but I don't think it's a great weight difference. The thing is, when that rocket does, when the plane does fly up to sort of 35,000 feet and drops the rocket, then the fuel is actually held in the other wing of the plane. And when that rocket drops off, there's a valve that will open and then let that fuel into the other wing of the plane and help rebalance it for when it's coming back to land. It takes about 5 minutes for the fuel to go through and help rebalance the plane. And the plane doesn't feel it too greatly, but it's still useful to have done. So yeah, thank you for those questions. I've now got another question for Goonhilly, and every time I do a presentation with Goonhilly, this question comes up, and that is, are there plans to reopen a visitor centre at Goonhilly? Ian.
Yeah, we would love to reopen the visitor centre. There is a visitor centre there. It was closed down, unfortunately, before we took over the site. And we've been concentrating on building up the business and doing the good work that you heard from Olivia before. So one of these days it will be on our it'll rise up our list of things to do. In the meantime, we do engage with an awful lot of people from Goonhilly, and we have a huge program of working with schools and universities. So we try and make up for it in that way. And you can get close to the site as well. With the there's a public car park nearby, and you can walk around the perimeter. But unfortunately, it's not open at the moment. Just quickly though, Dave, answering the previous question on applications of satellite into the health sector. Perhaps not directly an application of the satellite data, but the whole sector is a sector, as Olivia said, with people with very diverse skills, and particularly talking to this audience in the Institute of Physics. There's a huge amount of transferable skills within physicists, and particularly within communication engineers, and we do a lot of work on digital signal processing of the signals, and there are some really direct examples of image processing that has come out of really the communications world and the radio astronomy world, and I'm thinking particularly of we deal with signals that are very poor quality signals, that they've traveled all the way across space, very poor signal to noise, very poor contrast. And they're very typical of the type of, sometimes the medical images that you get. So there are plenty of examples where techniques developed by communication engineers have applications in medical imaging and medical diagnosis as well.
That's great. I guess that all comes back to that sort of STEM learning and transferable skills that are learned as well, really. Thanks for that, Ian. Always a tough question about the visitor centre, but hopefully one day we will see it in operation again. My next question is going back to Conrad, and the question is, how has Brexit affected the balance of funding for space sector activities, Are we still closely involved with ESA or just finishing off projects started with them and creating UK-only equivalents?
Very good question. And so our participation with ESA is definitely still there, and it's actually growing. So the UK is a member of ESA, the European Space Agency, which is an international organisation. So it's not, our membership with ESA is not affected by Brexit. So we can still go for funding opportunities, and they're coming out all the time. We have a regional ESA ambassador who helps to coordinate and gives guidance and advice for consortiums and businesses, and again, we can help. But also international collaborations as well. So ESA related ones, we're talking big, massive programs that could be lasting more than 10 years. We are still part of that. But because of Brexit, there is more onus on the UK and funding mechanisms for people with concept ideas to be able to innovate, and for SMEs to grow, and to primes to help out with the business growth. And again, we can help with that. So because of that, Innovate UK and sign up, and you'll be able to see the different funding opportunities coming up. They have things like smart grants. You can just have your concept idea. It's very competitive, but also because of the industrial strategy, there's different calls coming out, and they could be around smart transport, smart cities, smart ports, aviation, and lots of different funding opportunities for lots of different applications, basically. But then also we can help, as mentioned before, with people going for funding applications, and it doesn't matter who the funder is. It could be Research England, it could be NERC, it could be other UK-related funders, or we could help part of an international consortium.
Brilliant. Thanks for that detailed response, Conrad. Essentially, get in touch with Conrad is what I'm taking from this. If you're looking to get involved in the space sector and looking for funding, to touch base with Conrad and go from there. I've got a question for us now at Spaceport. How many SMEs are currently in the Spaceport cluster, and how many more do we expect in the coming years? So at the moment, we're developing our first sort of buildings on site, and they should be built by January. We ran 2 sort of business days last week, and it's looking likely that we're already oversubscribed for some of those SME spaces, but that gives us a real sort of impetus to be able to go back and ask for more funding to develop more for those SMEs. So at the moment in Cornwall, there's about 50 organisations involved in the space sector, and that's been more than, well, it's been about 160% increase since 2010. So it's a really quickly developing sector, and I think once we've brought launch to Cornwall, that's only going to develop faster. Thank you for that question. The next question is going to go back to Ian at Goonhilly. We speak about facilitating the launch of satellites, which suggests a significant increase in the number of orbiting objects. Do we have any projects related to detection of objects and increasing the safety of spaceborne devices?
Indeed, yes. One of the collaborations we've been doing at Goonhilly is with Oxford University. And we've installed a super cooled cryostat. That's a receiver on our second largest antenna. That achieves a temperature very close to absolute zero, about 8 to 9 Kelvin. And by cooling the receiver down to that temperature, then we pretty much eliminate all of the noise in the receive chain, if you like, and that makes an antenna which is very capable of spotting space objects, space debris, and satellites that perhaps might have lost their way, or may deliberately be doing unusual things. So recently we tracked a mission called MEV2. MEV was stands for Mission Extension Vehicle, and it was a planned satellite, very James Bond-like. So a satellite launched into geostationary orbit, and its role in life was to go and grab onto an existing but old geostationary satellite and provide it with some more fuel, essentially provide it with an extension to its life. And we were able to track the rendezvous of those two satellites and the connectivity using the antennas that we have at Goonhilly. And then again, working with the radio astronomy community, radio astronomers build networks of antennas called interferometers, where you interconnect multiple antennas together. And again, this creates not only a very sensitive network, but a network which can scan across the sky. And we're looking at a number of different projects where we can use radio interferometers. Normally, when astronomers are looking at the sky, they'd like to see a nice clean, clear sky with no interference. And satellites pop up within their images. So we can use what's normally an annoyance to radio astronomers as a means of detecting and helping to monitor where objects are in space.
You mentioned the docking of the satellite. Has that been done very often before?
It's been done twice now in geostationary orbit. So yeah, just a couple of months ago was the second occasion when it was done. And obviously, this is it's an interesting technique for reusability in space. And obviously, it's been done. You know, right back from the early Gemini days and Apollo, and then right through human spaceflight, it's been done. And with the International Space Station, the autonomous docking of robot ships to the space station is done on a regular basis. But this is the first time, essentially, a commercial geostationary satellite has had its life extended by this method.
Yeah, amazing. Thanks for that. The next couple of questions, I'm going to go back to Goonhilly with Olivia. And the questions are, what opportunities exist for data engineers in the expansion of UK space operations? And secondly, similar question really, what type of jobs are likely to be created in Cornwall, research or only operational? And I can jump in on the second part of that question as well.
Okay, yeah. So at Goonhilly, we are also developing a Space AI Institute. So I think there will be opportunities in that area. So in looking at applications of space data, like what Conrad has been talking about as well. So yeah, it's not just operational opportunities here, but a real mixture. I'd say a real range of opportunities should be available from operational research and yeah, lots of other opportunities really. I don't know if Ian has anything to add to that at all. Or...
Yeah, I think one of the the big buzzword of the day is AI and machine learning, and taking these techniques of using big data sets to allow the computer to compare and find differences in the data sets and learn and give us information out of those data sets. Again, one of the skills in satellite communications and in digital signal processing is actually working with real-time data. And for all of the techniques that have been developed in AI and machine learning over the last couple of decades or so, it's sort of setting aside all of the hundreds of years of physics learning that we've known. So we're very interested actually in sort of bringing those two together and saying, okay, the techniques of convolution that are involved in machine learning are very useful, and we've invested in building supercomputers at Goonhilly that can do those calculations at very high speed. But we're also interested in the R&D around using signal processing techniques, physics-directed algorithmic techniques, and Bayesian analysis to really bring that to look at a different way of acting on real-time data rather than relying on very large data sets in order to do machine learning. And I think there's a big movement now, especially with what we need to do in terms of the response to the global warming and climate change, in terms of using satellite data and essentially creating, digital twins and of systems, so that we can understand and really make whatever corrective actions we need to make and understand those and to be able to simulate those. So we're very interested in all of those aspects at Goonhilly, and we certainly intend to develop partnerships and to expand that capability here.
Great, thanks both. Just to add to that as well, just around that sort of research or only operational question, we work really closely with the University of Exeter, and there is a lot of development around the research within space, and there's a lot more sort of grant funding coming up around using and researching using space data and satellites. So if that is of particular interest to this questioner, then I would look into some of those areas as well. I've got a couple of questions for myself. Will the spaceport provide opportunities for public involvement in the science or data processing? So I'm not sure about public involvement in the science or data processing. So on our first launch, we are hoping to launch a small satellite that will look at some of the environmental concerns around Cornwall, so possibly looking at something within our oceans. And we are going to be hopefully working with schools across the county, schools, colleges, universities across the county to look at that data and use that data. But open, whether that will be open to the general public, I'm not sure yet. That's been quite a new thing. Another question is there a lead organisation in Cornwall for the industry to which all parties belong to? The structure for the whole is a little unclear. Is BAYS lead, or is there independent coordination in place? So the UK Space Agency is the lead for the UK that we're all part of, and BAYS is above the UK Space Agency. Locally as well, there's an organisation called Aerospace Cornwall, which is a sort of funding organisation that I think most of us are members of. But to be honest, we're a very close-knit sector, especially locally, and we all know each other particularly well. We're all part of different groups and different boards. So I don't think, Ian or Conrad might be able to correct me, I don't think there is a specific Cornwall lead, but please correct me if I'm wrong there.
Well, Dave, and I'm sure Conrad will jump in, but yeah, approach any of us, and we're all happy to help and signpost you in the right direction.
Yeah, and I was just going to add, yeah, so we're part of the Southwest or Cornwall Space Cluster, but the UK Space Agency and the satellite applications Catapult are developing and growing this UK Space Enterprise Network. So they've created a platform, and it's been tested on and developed at the moment. And hopefully in the next few weeks, whatever, it will become live, and that will be an opportunity for you to get involved. You can sign up and you can see what is going on in the UK around space activities, initiatives and capabilities, and you'll be able to zone in on what's going on in the Southwest. And so that's a national platform, and we will become a Southwest space enterprise gateway, and there's other clusters around the UK forming. So in the Wekalet, so the Bristol area, for example, they are forming a space cluster. But within the Southwest, as Dave mentioned, we're very close-knit, so just come and speak to any of us. We're here to help.
Great, thanks both. I've got 4 questions left. One for me now is, how does progress in Cornwall compare with Virgin Orbit's other launch sites? So I'll talk about Virgin Orbit's, and I'll talk about the UK launch sites as well. So I think there's the launch site in America, and the launch site in Guam is quite well advanced. And we're either level or just behind Guam as one of their most advanced spaceports. We will be the first launch site outside of the US. Japan in Wita are just at the development phase, so just trying to sort of get agreements with the local governments in place. And the one that Michael Lynn mentioned in Brazil was only sort of mentioned about 6 months ago initially to the public. The sort of developments at Spaceport Cornwall have been on the cards for about 7 years, so we are quite a lot further advanced, and the legislation's just gone through the CAA. So yeah, launch next year is very, very likely. And then in regards to the other spaceport sites, so there's 3 spaceports looking to be developed in Scotland, and there's 1 in Wales. But I would say that we're most likely to get the first launch next year, and then the most advanced after that is probably Shetland in Scotland, who are looking at a vertical launch site. But I think one of the big advantages that we've got is that we are developing on an airport, so the infrastructure is largely already there. You know, we could theoretically launch tomorrow if all of the policy and everything was in place for that launch, whereas I think some of the other spaceports have got more challenges in the fact that they are trying to build a spaceport where there has never been a spaceport. So I think that comes with its own challenges. But yeah, thank you for that question. I've got a final question for Conrad, and then a final one for Goonhilly, and then I've got a final one kind of for all of us to take. So Conrad, with Falmouth University listed as a partner for a lot of these projects, is there scope for collaboration with Falmouth students or courses beyond just Launchpad Business School, i.e. with the film or TV, photography, design, music, etc. departments?
Yeah, really good question. There's definite scope, and the Southwest Centre, we're developing a strategy for the next few years, and there's also developments at Falmouth University, and so they're all will hopefully be expanding their design thinking capabilities. And what that will mean is we could definitely be part of that to help with brainstorming sessions for people with concept ideas and really taking it further, getting to the prototype stage, and really help people on their business journey. So Falmouth University are definitely going to be a partner going forward. They've got some really interesting ideas and developments that, you know, there's talk behind the scenes that I can't mention now, but with the University of Exeter, and also just to mention, they are developing a space and extreme environments hub to help with research, space resources, working with our Camborne School of Mines as well, and also the University of Plymouth around marine and maritime innovation and cybersecurity, and also with Falmouth with their strengths with immersive technologies and things like that. It is a huge playing field and a blank canvas for people concept ideas, and we can help you commercialize these research ideas and really make a difference.
You know, if the person who asked the question is from Falmouth University and wants to set up projects with us, then I would say get in touch, because we always like to try and explore what is possible and try and give students a bit of exposure into the sector with real life projects as well. I've got a question now, final question for Goonhilly, and that is, what methods are used to avoid possible collisions with space debris?
Shall I go first? Liv, and you can add. So every space object is tracked. In fact, I think I may actually have my party case. No, I couldn't. I'll grab it. Reappears on the screen. But there is no other industry in the world like the space industry. This is a list of every single space mission ever. They're all here from Sputnik 1 in 1957, and I've got the entire catalogue of space missions. So they're all catalogued. Many of the spacecraft that were launched in the 1960s are still in space in orbit. And one of the key things about Newtonian mechanics, as you all know, is that we can predict those orbits very well. So each object is given a designator, so it has a unique number for that launch, and then as pieces fall off, whether intended or not, they're given a sub-catalogue number, and those are all tracked at the moment by the American military, but the catalogue is a public catalogue, so you can just log on, type in the catalogue number, and you get the Newtonian orbital mechanic numbers, and you can just plug those into a computer and get the details. It then becomes a matter of plugging those numbers into a big computer and working out what the collision risk is, and that process gets more difficult as more and more launches happen, and as we move from a phase where the whole industry has been highly regulated and we've got this catalogue, to whether we get to the stage where it becomes more chaotic and people launch without going through the sort of normal process. I don't think we've got anywhere near that stage yet. But it's you know, as more and more objects get launched into space, it becomes harder, but it's a computational problem after all.
Great, thanks, Ian. Olivia, did you have anything you want to add in around like specific satellites and how they may, if they are on a collision course, how they may not be on a collision course?
I don't think I've got anything particularly to add to what Ian said there, just that there is a good website you can go on called Stuff in Space to actually look at them in real time. So it's quite a good one to check out.
Great, thank you. And I do know of organisations like sort of Avanti Communications that can communicate with satellites just to move them out of their orbit slightly and then bring them back if it has been identified that they're going to be on a collision course with something flying through space. Okay, we've got one final question, and I've saved one of the most important questions for last, and that is, how can we reassure those concerned about the environmental impacts of space? So I can start off with that one, and if anybody wants to jump in afterwards, then feel free. For me, I think I really see space as part of the solution to some of the environmental challenges that we have. I think by using space data and being able to track emissions and impacts by using satellite data, we're able to inform policy and really change mindsets of people. And I think a lot of the environmental knowledge that we have comes from satellites. So there's a few great sort of examples. There was one in Italy during COVID, actually, where they looked at the carbon dioxide emissions over the whole of the country pre-COVID, and then they also looked at a picture of it during COVID, and there was understandably a huge drop-off. But when that was shared, there was a lot of social pressure in Italy to change some of the things in the major cities, and there have been some really positive policy changes that have taken place since that data was released. From the spaceport perspective, we've done a full environmental impact assessment of what impact launching rockets to space is going to have from Cornwall, and at full capacity, so 8 launches a year, we'll have a 0.04 to a 0.1% increase in the amount of emission levels for Cornwall as a whole. But we are looking to offset that by investing in the green buses for Cornwall, but also by working with the universities and the university students around specific projects of how satellite data can be used. So we're doing 3 projects at the moment with students, one looking at sort of blue carbon, one looking at farmers and farming, and then another one looking at more generally about using sensors on the ground to help detect changes. We are slightly over time, but if anybody's got anything that they would like to add to that quickly, then feel free. If not, I'm going to pass across to Tarek, who will do a closure for this session. Cool. I will pass over to Tarek, I think. Thanks everybody for all of your questions. That they've been brilliant, and thanks to all of the presenters on this for a really sort of informative, inspirational session.
Thank you very much. It was a real pleasure to have everyone involved in this Stepping into Space session. We covered quite a lot of ground. We learned about the diversity of space applications from medicine to mining. We've heard about the opportunities either for young people and people who are perhaps mid-career thinking about changing, using their skills, technical and otherwise. It was also great to hear from Ian some cutting through the hype of data and AI and really explaining how some of the real challenges are around real-time algorithms and real-time data processing. So I think the message for me is that there's a lot happening in Cornwall. We should keep talking about it and raising awareness. The sector, technology and space, is growing. There's a lot of enthusiasm, and people will always say that when they visit Cornwall and meet us, they can tell that there's a lot of collaboration that happens. I think growing the community is part of the challenge, the community that underpins the people who work in these sectors, who can learn and share from each other. So it's quite an exciting time. The Institute of Physics is really pleased to have hosted this. We've learned a lot. And I think the final message for people listening in and joining in this session is get involved, contact everyone here. If you have ideas, if you have questions, get involved in some of the community groups, get involved with the aerospace organizations, and they will help you and point you in the right direction to get your ideas off the ground. So thanks very much, and thank you everyone for giving us your time and sharing what an exciting things that you've been working on. Thanks very much. Thanks.